OpenAI spent over $100 million training GPT-4. That's more than the entire operating budget of most AI research labs, and they're not done spending. Most of that money didn't go where you'd expect. It wasn't salaries or office space. The largest line item was compute, thousands of high-end GPUs running continuously for months. And the cost curve isn't flattening, it's accelerating. GPT-5's training budget is projected to be several times higher, possibly crossing into the billion-dollar range. So where does $100 million actually go when you're training an AI model? Start with the hardware. GPT-4 was trained on an estimated 25,000 NVIDIA A100 GPUs. These aren't consumer graphics cards. Each one costs between $10,000 and $15,000 at enterprise pricing. But OpenAI didn't buy them, they rented them through Microsoft Azure. The rental model changes the math entirely. You're not paying for the hardware itself, you're paying for compute time. And at scale, compute time is astonishingly expensive. Industry estimates place Azure's cost for high-end GPU clusters at around $2 to $3 per GPU per hour. Run that calculation, 25,000 GPUs running for an estimated 3 months at roughly $250 per hour per chip. That's about $45 million in raw compute rental alone, and that's conservative. Some analysts believe the training run took longer or used more hardware during peak phases. But compute rental is only the beginning. The second cost is electricity. Training GPT-4 consumed an estimated 50 gigawatt-hours of power. To put that in perspective, that's enough electricity to power over 4,000 US homes for an entire year. At commercial data center rates, electricity for a training run of that scale costs between $3 and $5 million. Microsoft, which provided the infrastructure, doesn't publish their energy contracts, but they've acknowledged that AI training is now one of their largest electricity expenses. Then there's the cooling. High-density GPU clusters generate extreme heat. Keeping them operational requires industrial cooling systems running continuously. Data centers typically spend 30 to 40% of their energy budget on cooling alone. Add another $2 million. Storage costs matter too. GPT-4 was trained on an estimated 13 trillion tokens of data. That data doesn't just sit on a hard drive, it needs to be served to thousands of GPUs simultaneously, which requires high-speed distributed storage infrastructure. Estimates place this cost at around $5 million for the duration of the training run. But the most expensive component isn't hardware or electricity. It's the engineering talent required to make the training run actually work. Frontier model training doesn't happen automatically. It requires a team of researchers and engineers monitoring the process constantly, debugging failures, adjusting hyperparameters, and restarting when something breaks, and things break frequently. OpenAI employed an estimated 50 to 75 engineers and researchers directly involved in GPT-4's training. These aren't junior developers, they're specialists in distributed systems, machine learning optimization, and large-scale infrastructure. Industry salary data suggests total compensation for senior ML engineers at top AI labs ranges from $400,000 to over $1 million annually when you include stock and bonuses. Even at the lower end, that's a personnel cost of $20 to $30 million during the training period, accounting for the portion of their time dedicated to this specific project. Add in adjacent costs, project management, internal tooling development, data pipeline engineering, and the human capital investment rivals the compute costs. Then there's the invisible expense, failed experiments. The $100 million figure represents the successful training run. It doesn't include the attempts that didn't work. Training runs fail for dozens of reasons. Hardware malfunctions, bugs in the training code, hyperparameters that seemed promising but led to unstable models, data quality issues discovered halfway through. Each failed experiment costs money, not the full $100 million, but enough to matter. If OpenAI ran 3 or 4 serious attempts before the final GPT-4 training run, a conservative estimate based on industry norms, the total research and development cost could easily reach $150 to $200 million. OpenAI has never confirmed this, but former employees have described a culture of experimentation that involves running multiple parallel training attempts with different architectures and hyperparameter choices. Only the successful ones become products. So when you hear GPT-4 cost $100 million to train, understand that's likely the lower bound. The true cost of delivering GPT-4 as a product is higher. Now consider what's coming next. GPT-5 is reportedly in development, though OpenAI has been strategically vague about timelines. But we can make educated projections about cost based on what the company has said publicly and what industry trends suggest. Sam Altman has stated that future models will require significantly more compute than GPT-4. Microsoft announced in late 2024 that they're building new data center capacity specifically for OpenAI's next-generation training runs. These aren't expansions measured in thousands of GPUs, they're measured in tens of thousands. If GPT-5 uses 5 times the compute of GPT-4, a reasonable estimate given historical scaling trends, the training cost jumps to $500 million. If it uses 10 times the compute, you're approaching $1 billion. The economics become genuinely strange at that scale. $1 billion training run means you're spending over $10 million per day while the model trains. That's more than most companies spend on research and development in an entire year. And the returns aren't guaranteed. You can spend $1 billion training a model and discover it's only marginally better than the previous version. There's no refund. The compute has been consumed. The electricity has been used. The money is gone. So this creates a structural problem. Only a few companies can afford to play this game. OpenAI has Microsoft. Google has its own infrastructure. Anthropic has significant backing from Google and Amazon. Meta funds its AI research through advertising revenue. But the barrier to entry is no longer just technical expertise, it's capital. If you're a university research lab or a startup without massive funding, you cannot train a frontier model. The cost is prohibitive. And this has implications beyond competition. It means the companies that control frontier AI are the ones with the deepest pockets or the strongest corporate partnerships, not necessarily the ones with the best ideas. And the cost curve shows no signs of bending downward. Every generation of models requires more compute, more data, more infrastructure. The training cost for GPT-6, if it happens, could easily exceed several billion dollars, which raises an uncomfortable question. At what point does the cost become unsustainable? OpenAI spent $100 million training GPT-4, and they're preparing to spend several times that on GPT-5. But they still haven't proven that AI models at this scale can generate more revenue than they cost to create and operate. The money keeps flowing, the training runs keep getting bigger, and no one seems entirely sure where the economics lead, just that someone, eventually, will have to pay the bill.